Good morning, student. Today we will discuss the type of mechanism involved during growth of polymerization. Nowadays, polymers are also classified on the basis of mechanism involved during the growth of polymerization chain. We have already learned about addition polymer and condensation polymer. On the basis of mechanism, the addition polymers are also called as chain growth polymer. And the condensation polymer are also called as step growth polymer. We will discuss the mechanism of chain growth polymers. The type of polymerization is also called chain growth polymerization, and the polymer thus formed are also called chain growth polymer. This chain growth polymers proceed through three types of mechanism. First is free radical polymerization mechanism. Second is cationic polymerization. And third is anionic polymerization, carbanion ion polymerization. Cationic polymerization, they are also called carbocation polymerization. First, we will discuss free radical polymerization. A variety of unsaturated compounds such as alkenes and their derivative undergoes polymerization in presence of free radical initiator. These free radical initiator are obtained by dioxygen or benzoyl peroxide. These initiator molecule readily decomposed on mild heating to form initiator free radical. For example, when benzoyl peroxide heated, it gives phenyl initiator for free radical. Benzoyl peroxide is used to generate free radical. It gives phenyl as a free radical. The overall mechanism takes place in three steps: chain initiating step, chain propagating step, and chain terminating step. Let us take the formation of ethene molecule. We will take the mechanism of formation of ethene molecule. The simple reaction is CH2 double bond CH2. We will take n times of molecule. They undergo polymerization at high temperature between 350 to 570 Kelvin and high pressure, and in presence of a free radical generator such as benzoyl peroxide. And we get polythene. This reaction takes place following types of mechanism. This reaction proceeds with the following mechanism. This mechanism is three parts. In first step, in presence of high temperature and high pressure, the benzyl peroxide breaks down into free radical phenyl. Phenyl as a free radical, like this. This is the formula of benzyl peroxide. This is benzyl peroxide. In presence of high temperature and high pressure, it undergoes homolytic fission like this. So we get two molecules of C6H5COO. This further undergoes dissociation. We get C6H5 as a free radical, phenyl as a free radical, and two molecules of carbon dioxide. Now this phenyl free radical, it attacks on it attacks on ethene molecule. This free radical phenyl, it attacks on this ethene molecule, which is act as a monomer. This phenyl attack on this carbon, pi bond shifted to this carbon. This is a heterolytic fission here. Now we get C6H5CH2 as a free radical. We get another free radical. This is known as phenyl free this is known as bigger free radical. We can say it as a bigger free radical. 1. Now this free radical further reacts with ethene molecule and give another bigger free radical. So this is the first step, which is known as chain initiating step. Second step is chain propagating step. In this step, this free radical again react with ethene molecule, which is a monomer, and we get another big free radical. This reaction goes on and we get a very big free radical which contains large number of ethene molecules. Now last step is chain terminating step. Chain termination can be done by two ways. In first step, by combination of free radical. Here, two molecules of these free radical, they combine like this. These two free radical here combine with these two and we get polyethylene. The second method for termination of chain is by disproportionation reaction. Here we will take again the big free radical which we obtained in second step. another molecule. In this case, one H from here will goes to this, and this proportionation takes place. We get one molecule this, and here we get double bond. So this is the free radical mechanism for the formation of ethene molecule, polythene molecule. In this, monomer use was ethene. The other type of mechanism is carbocation polymerization. This was first mechanism, free radical mechanism. The other second type of mechanism is this is called cationic polymerization. This type of mechanism contained in certain alkene monomers. The cation obtained in these, the reaction occur in a strong protonic acid. Reaction occur with the help of strong protonic acid such as sulfuric acid or Lewis acid. Lewis acid we know AlCl3, BF3, etc. For example, if we polymerize isobutylene, formula of isobutylene is CS3, CS3 double bond CH2. This is single bond. This is isobutylene in presence of Lewis acid such as H2SO4, AlCl3, BF3. This H plus comes from acid at 193 Kelvin. Here this pi bond will goes to this and H comes here. We get this carbocation. This type of mechanism takes place where carbocation is stabilized. Now this carbocation again combined with another molecule, and we get this another carbocation. So this reaction goes by addition, by adding this molecule, and finally we get polymer of isobutylene, polyisobutylene. So this mechanism is called cationic mechanism. In this mechanism, intermediate is carbocation. Another mechanism is, the third type of mechanism is carboanion, or we can call it as anionic polymerization. Alkene monomer with electron withdrawing substituent can be polymerized by anionic mechanism as well as by free radical mechanism. So condition for anionic polymerization is that the alkene which contain electron withdrawing group. For example, if we take this styrene. In this styrene, this phenyl is electron withdrawing group. If we if we treat this with strong base such as this KNH2, we get this type of mechanism: NH2, CH2, CH, C6H5, negative charge. This again react with C6H5, we get NH2, CH2, CH, C6H5, CH2, CH2, with K plus. This reaction goes on and finally we get CH2, CH, C6H5 n-time. This is called polystyrene. Greater the stability of carbanion ion. Here in this reaction we get carbanion ion as intermediate. So greater the stability of carbanion ion intermediate, more will be the anionic polymerization. Thus alkene containing electron withdrawing group such as acrylonitrile, methyl acrylate, styrene can be polymerized under anionic condition, although free radical polymerization is commercially preferred. So we get that we discuss here that the addition polymerization, that is also called chain growth polymerization, occur through three types of mechanism, that is free radical mechanism, cationic mechanism, carbocation mechanism, and anionic polymerization or anionic mechanism. Thank you.